AP Calculus AB, section 4.2, page 1. This section is called or entitled the mean value theorem. First, before we get to the mean value theorem, we need to refresh your memory on some review of precalculus. And we need to remember about what it means for a function to be increasing. A function is increasing if and only if f of x sub 1 is less than f of x sub 2 whenever x1 is less than x sub 2. Alright, let's sketch a graph here so if we can see and follow what that's talking about here. We've got some x value, x1, and another x value, x sub 2. And we want that f of x sub 1 to be smaller than f of x sub 2. So the function value for x sub 1 here and the function value f of x sub 2 is larger. Right? Well, clearly this function is increasing. As we connect those dots, that function is increasing. Now I drew this almost linear here. Just a couple other ways that this could have been drawn. We could have put those points like this. And we could have had this graph kind of curving upwards. It's still an increasing function, and I also could have had this graph curving downwards as opposed to being linear like this one. That's still an increasing function. It's just curving downward. There's your increasings. If we look at the definition for decreasing, very similar. A decreasing function, or a function is decreasing if whenever x sub 1 is less than x sub 2, but this time the y value at x1 is larger than the y value at x sub 2. Y value at x sub 1 up here larger than the y value at x sub 2. And again, several ways to draw this. We could have a linear function in here, or let me label this. Okay, one of the options, instead of linear, we can have this function kind of curving upward. Still a decreasing function. The y values are getting smaller. Or we can have this be curving downward. Y value is still getting smaller, but the shape of the curve is a little different. All right, then again, some more review of Precalc. Let's take a look at this curve. When we look at this curve, we can say that this function is increasing on the intervals from negative infinity up to b, right up to here. Also increasing from d up to infinity. And the graph then is decreasing on the interval from b to d. All right? So, review of Precalc. Let's step this up a bit and see how that relates to calculus, and talk about something called the first derivative test. If f of x is continuous on some closed interval from a to b and differentiable, means the tangent line exists, the slope exists, on the open interval from a to b, then if f prime of x is greater than 0 for all x in that interval, then f of x is increasing on that interval. Oh boy. All right, first thing this says for us is right here, f prime of x greater than 0. Think about that. F prime is slopes of tangents. So this is saying the slopes of the tangents are positive. And that makes sense. Up here where we said increasing, all these slopes in here are positive. Likewise, over here, slopes are positive over here. So again, if f prime of x is greater than 0, positive slopes of tangent lines on this interval, then f of x is increasing on the interval from a to b. Now, just a note, some textbooks will say that f of x is increasing on the closed interval from a to b. It just depends on the author of the textbook. I won't make this a big deal between open and closed. I will pretty much always use open, but if you write closed, that's fine. Likewise, on the AP test, for an interval of increasing, they will accept an open interval or a closed interval. If we look at the decreasing here, so this function is decreasing when f prime of x is less than 0. That's talking about slopes of tangents are negative. So if slopes of tangents are negative, then f of x is decreasing on that interval. And again, perhaps you are more comfortable using closed interval. And that's the end of page 1. Please join me on page 2.